Hello guys, today I'm gonna make finding limits very simple. And yeah, you should be able to find most finite limits, or define if they are undefinable after this video. You will need some calculus and algebra knowledge, but that's about it. Okay, so let's say we have to find the limit as x approaches, let's say, 3 of 5x minus 4 plus 2. Now the thing is, if you've got a limit that's not that scary looking and stuff, something like this, the first thing you usually want to try is plugging in the value x is approaching toward into this equation. So this should be equal to 5 times 3 minus 4 plus 2, because we've changed the x to the 3, right? We've plugged the 3 in. So that's going to be 15 minus 4, that's 11, plus 2, that's 13. Boom. And many limits you'll find are actually going to be that simple when you're actually doing some other stuff. But usually on our tests and stuff, it's not going to be that simple. And sometimes it's not going to be that simple in your cases, in your personal cases. So, it's also useful to know what to do when it's not that simple, right? So let's say we have a limit as x approaches 3 of fraction, and let's say that fraction is x squared minus 1 divided by x minus 1, right? So whenever you've got a fraction, what you want to check is if the denominator, bottom part over here, if it's going to be something valid, okay? And by invalid, I mean if it's 0 or if it's infinity. Because if in the last method, something results in 0 or infinity, sitting with something, then that's a problem, okay? So over here, we won't get 0. We will just get a normal number 2, right? So we have 3 squared, that's 9 minus 1, that's 8. 8 divided by 3 minus 1, that's 2. So 8 divided by 2 is 4. Great. So if the bottom part of the fraction works out, it's a normal, then you can just plug in the value. But sometimes it's not as simple as that. For example, let's say we have x approaches 1 of the same fraction, x squared minus 1 divided by x minus 1. So we have this, right? And we have, so if you try to plug in for the x, the 1, you will find out that the denominator will be 0, which is bad. And over here, we also have 0, right? And I actually spoiled this a bit because I wanted to say, if you ever, in the bottom part, you get something invalid, so, a 0 or infinity, the first thing I would do is try to find out what the top is. Okay. So, over here, the top is going to be 0 as well, since 1 squared minus 1 is 0. Now, if you have an invalid thing over an invalid thing, that's not the limit. But you can use the L'Hopital's rule. Some people say the hospitals. That's incorrect, but, just saying in case somebody says the hospital's rule and you don't know what he's talking about, but it's supposed to be pronounced L'Hopital's rule. And L'Hopital's rule basically says when you've got a limit of such a fraction, where you have either infinity over infinity or 0 over 0, not infinity over 0 or 0 over infinity, just 0 over 0 or infinity over infinity, you can actually rewrite this as the limit as x approaches that value, the same one, which is 1, and instead of having the same fraction, for both parts, you would just have the derivative. So the derivative of x squared minus 1. So we ignore the constant, negative 1. So x squared, the derivative of x squared is 2x. Over, we ignore the constants, constant negative 1. And we only have x over here. So this is basically 1, since the derivative of x is 1. And let's try plugging it right now. Okay, so we get 2x, which is just 2 multiplied by 1, over 1. So that's 2 divided by 1, and that's 2. So we've just found a limit using L'Hopital's rule, right? So if you were to have something like, I don't know. If you had the natural log of x, or 0, over the natural log of x, 0. That's infinity over infinity, right? You get my point, okay? But sometimes, let's say we have a scenario like, let's get the limit as x approaches 0 of, let's say, x over the natural log of x. Okay. So whenever you have a situation where it's 0 over infinity, you cannot use L'Hopital's rule, because it's even simpler. Because whenever you've got a limit which results in 0 over infinity, the value of the limit is simply 0. Okay? Here's your answer, 0. Now, let's say we have something that says x approaches 0. We have x plus 1 over x, right? So here we have a situation where we have 0 in the denominator, but we have 1 in the top part. Now, what do we do in this case? Well, we gotta check if there's any way to algebraically manipulate this equation in order to get the limit. But sometimes there is none. And if there is none, it means the limit doesn't exist. It means that the function, it basically doesn't have anything at that point, right? So it means it's not really continuous, right? So whenever you've got 1 over 0, or anything over 0, in such a case where you can't manipulate it, this limit is basically going to be non-existent. So what we can write is the limit as x approaches 0 of x plus 1 over x diverges. You can also write does not exist, or we can write is divergent. Okay? But there are some cases where you can algebraically manipulate your equation. Let's say we have the limit as x approaches 4 of x minus 4, and then in the top part we have x squared minus 9x plus 20. So, I'll just quickly go through the process because I don't want to make this video too long. But, well, if you have something like this, then what you can, for example, do, well, we see that we have 0 in the denominator, but what I'm going to do in this case, in order to manipulate it, what I'm going to do is factor it. So, first, well, before factoring, I'm going to split this 9 over here. So we're going to have x squared minus, 4x plus negative 5 x, right, plus 20. And then we can factor it. So here we have x, right? So we can rewrite this entire thing as x times, 4, well, we will have x divided by x squared divided by x is x, and then we have 4, and then we have still the other one, so I'll factor it. So a common divider of that one, it was -5, so we can just write -5 times and the first expression, it was just x minus, and 20 divided by -5 is -4, so we'll write that. And then we see another common divider, which is x minus 4. So all of this just becomes x minus 4 times x minus 5. And we have all of this over x minus 4, right? So, of course, this cancels out. So this is x minus 5, which means this entire limit is the same after manipulating it algebraically as the limit as x approaches 4 of x minus 5, which means that this is the same as 4 minus 5 or -1, right? We found the limit. Okay, sometimes you're gonna have hard examples like that. Another case I'm gonna mention, and probably the last one, if I haven't mentioned it, is when you have infinity over 0. And if you have infinity over 0, I wanted to say 0 here. Okay. If you have infinity over 0, it means it's divergent. This function is divergent. This limit does not exist. And okay, that's pretty much it. So this was making finite limits simple. You can probably do most finite limits at your current state. So yeah, I hope you enjoyed this video, and see you.